Hi, welcome to Anderson Griffin's 6th tutorial in Matlab in this series. Area processing. Some of the commands we're going to be looking at: imrotate, imcrop, imresize, fspecial and imfilter, and if we have time, imtransform. Okay, so we have met imresize already. That was in the context of point processes. Now imresize is an area process command, but we just had to use it to illustrate some areas in point processing. So first thing is we're going to do is we're going to read in our Sorrento image. I'm not going to display it because we've seen it already, and I'm going to grayscale it. Okay, so what we're going to do now is we want to make that, say, be grey much bigger. So we'll say, so we hit return here, and the command here is imresize the array or the variable, comma, and what we want to do in 2 means make it bigger, well, twice as big. Just type a who's here. Okay, and you can see that 960 by 2 is 1920 and 1280 by 2 is 2560, and if we wanted to halve the size, we'd say be grey halve, and we put in the scaling factor here, and we do a who's, and we can see that 960 divided by 2 is 480. Due to time limitations, I'm not going to display them, but if you're doing this on your own, you would be able to do so. Okay, so we've done imrotate. Next command up is imcrop. So crop, as you would know from possibly Adobe Photoshop or some other image processing, would be to make the image smaller. So what we're going to say is be grey crop equals imcrop, comma, the variable, and the variable is be grey. Hit return. We see the image has popped up. We used a cursor. Hopefully you will be able to see this in YouTube. Might be able to, but the cursor there is just in the top left hand corner, and we click and we drag and we right button click and we say crop image. Shut that down. Do a who's, and you see the be grey crop is a much smaller. Let's look at be grey crop. Okay, and you can see that we've cropped the image, and you should be able to, might be able to see the detail in YouTube, but you can see that we have cropped the image. Okay, so that's imcrop. We've shown imresize, and the next one is imrotate. So we're going to say be grey rot nearest equals imrotate the variable name, comma, how much we want to rotate it by, and that is in degrees. So we're going to say, for the sake of argument, 30. Semicolon, just to suppress the output because the numbers will just spill all over the screen. Let's have a look at that. And there it is. Okay. Now, if you've attended lectures or you've read up the relevant books, imrotate can take 3 parameters. That's nearest, bicubic, and bilinear. And they are in increasing order of quality. So nearest being the worst, bilinear in the middle, and bicubic being best. Okay, so nearest, worst, bilinear in the middle, and bicubic best. It's beyond the scope of this tutorial to explain what they are, that would be left to the student to either attend lectures or read the relevant book. But we could say something just so we're aware, something like that. You can put in this. And so what you're saying here is we're telling it be grade nearest, and just to do that, and we're saying using the nearest option. Okay, had it in the wrong place. We can say by cubic, which, as I said before, is the best. And there we are. Okay, so that's it. That's up to that. Next area commands we want to show is fspecial. Okay, I have some of them here lined up from before. So what we've done here is we're going to do some convolution, and we've created a 3x3 averaging filter, again beyond the scope of this lecture or this tutorial to explain what's going on. The student should be aware of what's going on. So we've created that filter, which is an averaging filter, and the command down here is, what we're going to say is we're going to implement that. So we're going to say filtered b gray equals imfilter the image, which is b gray, and then using the filter. So that's filtered b gray by the filter we've created, which is an averaging filter. Okay, let's have a look at it. So there we are. Mightn't look that good there. So we've created a 3x3 averaging filter. You mightn't be able to see it on YouTube. What's going on? Let's create a bigger averaging filter. H1A, and we're going to make that 11. So this will be 11 by 11 averaging filter, and now we're going to filter it. And we're going to say H1A, and we're going to call this, the names are getting quite long now, H1A. And now let's show it. And when we use a very big filter, we should get quite a noticeable average, a noticeable blurring. And on my screen it's quite pronounced. Hopefully on YouTube it is